Testing 1, 2. I have no idea if my voice is too soft or compared to music. So someone let me know. Orientation. Okay, so we have a dupe pieces. And yeah, well, we can just borrow the orientation from the same piece to begin with. Also, so if you rotate the top, then all the colors that are at the top, I have to fix my Hello, Cotarino. Merry Christmas. I'm fighting my own music because it's too loud for me. Let me see. Oh, that also influences the strength that you guys hear it, I think. Yeah, I think the output of this is used to send it to OBS. I don't know. Is it too soft, too loud? Tell me, please. I can change the volume down from this point on, if you want. Okay, so I guess you were not here yesterday, obviously. My cube works as follows. We store the stuff in 2 arrays, pieces and orientation. And the index of this array is shown here. So if the cube is soft and the top is blue and the front is red, and that is the orientation of the cube in soft state. So if I have it soft but blue is not at the top, it's gonna say that it's not soft. Yeah, I mean, yeah. So that I have a list of all the pieces here that exist, 8 pieces. And then the first one here is, well, if it is a piece on the top, then the first color is the color that is at the top. And if it's at the bottom, then the first color is the color that is at the bottom. So in the solved state, the blue is at the top, therefore also the orientation of the pieces is with blue first, because, well, they are on the top, and green is at the bottom, etc. So if I want to change the orientation of a piece, then I just have to rotate these 3 colors. And yeah, for example, we start with red, and then the next one becomes yellow, and then the last one becomes green. Or it is yellow, green, red. You say you have, of course, four faces. It's a cube. We have 6 faces. It's a 3D thing here. It's 1, 2, 3, and then the backside. Again, 4, 5, 6. But yeah, anyway, you know, so this little corner here has 3 orientations, with the current thing on the top, or if you rotate it a little bit, then this side becomes on the side here, and this side gets there. If you rotate it again, then this side got there, and this side got there, and so on. And I rotate it again, then it's again in the same position. So we can just denote the orientation of this piece by simply giving the color that is at the top. And that's what I do. I had a copy here in order to write this. You might as well look at this. So this means we rotate the top layer 1/4 clockwise. So piece number 3 comes at the position of 2, 2 goes to the position of 0, 0 goes to the position of 1, and 1 goes to the position of 3, which is written down here. But also the orientation, well, actually the orientation doesn't change in this case, because the orientation is denoted by giving the color that is at the top. And this piece has whatever color is at the top stays at the top. So the orientation is not changing for any piece. But we do, of course, need to maintain the orientation. So also the orientation of this corner becomes the orientation that this corner had, because, well, this corner is now moving there. So that's what this is doing. But there is, for the top, there is no reason to call do orientation afterwards, because this already does everything. But if we, and the bottom is the same thing, because, well, the color at the bottom stays at the bottom. But if we do left, then we must do more. Let's do first right, at least you can see the thing. So right is this side here, and then clockwise that way means that 1 goes to that looks like anti-clockwise. 1 goes to 3. Yeah, that is wrong. This is also 0 goes to 2, huh? No, this position, the position at 0 becomes a 2. So that's clockwise. And here 1 becomes 3. Yeah, it is clockwise. It is correct. Now how do we encode the orientation change here? So this thing is rotated a quarter clockwise, which means that this piece ends up here, and the orientation is then the color that is at the top. So that was the color that is here at the front. We can only talk about the colors at the top, so that is then the color at the top, but rotated clockwise 1, 2, or anti-clockwise 1. Let's say I express it in does it really matter what I do? I have to name this face. I think I'm gonna name it something positive. So this is 0, 1, and 2, which would be the index in the sides array of the piece. And I'm just going to type 2, which is then this side, because that one ends up at the top. So 2, and then it must know which piece that is, of course. Well, that is then the piece that ends up at this location, which is 1, which is, well, why not the first one, because I call this one 1, so that would be this position, and then that color comes there at the top. Okay, so then the next one is 3, which is this one. So we have to name the top color again, and it came from here. So that is this face. Which is I think 1. Okay. Okay, the next one is 5, this position, it came from there. So the color that ends up at the bottom is the back of this top thing here, which is 1 clockwise rotation away from the top. So there's also a 1. And then the last one is 7. And the color that ends up at the bottom. I was just talking about that one. This isn't easy. I have to do that. I have to do the 3D rotations. I'm looking from all sides in my head. But again, once we have those 4 numbers and then that 4 times, so it's 16 numbers in total. Once I have that, then the rest is just code, I guess. But yeah, let me get the numbers. Okay, I'm gonna do it differently. I'm going to denote the number of times you have to rotate the orientation clockwise. So this becomes here, and we maintain the same color, the same orientation. So what is at the top stays at the top, which means that it's actually rotated well, like that. But we don't want that. So that thing has to come on top, so we have to rotate it clockwise with one position. That's for 3 to 1, yeah, and now we get 7 to 3. It means that the bottom ends up at the top if we don't do anything about it. How did that work? I think this is just to swap, so this thing ends up here, but it should have ended up there. So then we rotate that twice. And then 5 to 1. Yeah, 1 to 5. 1 goes to 5. And the top ends up at the bottom, but the back thing should have ended up at the bottom. So we see the back should have ended up. I think the back ends up here, which means that if we look from that side, you have to rotate 2 clockwise. Yeah, I'm 99% sure. The last 5 goes to 7. So that thing is orientated like that. But like that. So the back face should come at the bottom, but it ends up here. So we have to rotate that thing 1. Okay, I think that's correct. Now I have to do that 3 more times. Left. It's even better because now I can't see the blocks. I can use the actual thing that I have here, I guess, to look at. Okay, so 4 goes to 0. Is that clockwise? Yeah. Which means that we want the back face to end up at the top, but the back face ends up there, I think. So we have to rotate it anti-clockwise, so there would be a 2. And this is 0 goes to 2. There must be a 1. Then we get 6 goes to 4. And that must end up that is a color we want. But it is like that. So that's also a 1. Maybe it's logical that it is the opposite of the other one. It is probably 2. So 2 goes to 6. And that is the color that should end up at the bottom, but it ends up there. Therefore, that is a 2. Yeah. the front. If we rotate the front a quarter clockwise, then 6 goes to 2. And we want to have the face of 6 that is now on the left to end up at the top, obviously. But by keeping the orientation the way it is, we think that the bottom color is at the top. Which means that the color that should be at the top ends up here. So we have to rotate it anti-clockwise. And 2 goes to 3. So we want the left color to be at the top. But the same color stays, so it ends up here. So it should be rotated a third clockwise. It's probably going to be 2 1 1 2 again. As if it is logical. 7 goes to 6. No. 2 3. 7 goes to 6. Oh, the order is random. Yeah, never mind. It's just the increasing order here, but it's like dunk dip dip dip. Okay, so we do this one. 7 goes to 6. As again, the bottom stays at the bottom because of the orientation. But we want to have this side here to end up at the bottom. So this side, if the bottom stays at the bottom, then this side becomes the front, and that should be in the bottom. So we have to rotate it 1 clockwise. I'm gonna guess so. This is just 2. You know, do we really have to verify that? That is well, actually, it is a random, so it's kind of it could have been 2 1 2 1, I suppose. It's not going to be 0. We're definitely going to have 2 1s and 2 2s. Yeah, so well, must be a 2, but might as well check it. So this is 3 goes to 7. And we want this side to end up at the bottom. But we keep the top at the bottom at first, which means that this side ends up here. That means that we have to rotate it anti-clockwise. Yeah, that's a 2. And then the back. Well, it's probably 1 2 2 1, but 1 goes to 0. Yeah, that is a 1. 5 goes to 1. That is a 2. 0 goes to 4. That's also a 2. 4 goes to 5. It's a 1. Yeah. Okay, so now to write that function. So the others have these are just 2 orientation 0 0 0 0 twice, so I don't call them. Probably should pass that as an array as well. Clockwise rotation, basically. Okay, so this means that after doing the permutation, I still have to update the orientation by rotating the orientation this many clockwise. Means that we have to change an orientation. What is the index of the orientation? Oh, beautiful. That depends on this array, which I lost. I might as well add it to the same function then, I suppose. Maybe that makes more sense. So then I am going to add the zeros here. Let's waste some CPU. Okay, so again, was 4 goes to 0, and then I have to do an anti-clockwise 1/3 rotation for the orientation. So where is the thing then at that point? This is left. Left here, clockwise, and I've got the numbers 0 went to 2, or just left. No, 4 goes to 0. 4 goes to 0. Okay. So yeah, that ends up at 0, and then we have to rotate it afterwards. So we should change whatever is at index 0, which is left, which is the 2 1. Yeah, 2. So that is the 2 1. So we assign currently this to the 2 index, but we need an extra rotation. clockwise rotation. Now the orientation that I have here is just a color. So how do I get a rotated color? You can only get that by see, it's I don't think it's smart to use colors actually then in orientation. It should have been indexes. Index into the piece itself. Can we change that? So I want to change the meaning of orientation from a color also to an index, and well, an index into a piece, or rather the array of a piece. So the piece has an array, so into sides. The index into sides. Yeah, there's also this index and is again an index to get the piece. So I might as well say pieces. So now instead of the color, so this is pieces and then array, so that would be this part, and that X is the sides, and we use as index 0. So this becomes 0 because, well, now we store the index directly. Same thing. Print. See, here we had to do a search for the correct thing. That is no longer necessary, I think. So I think orientation now stores S directly. Or yeah, P. So S is the side. We can get rid of all of this, or S is now equal to orientation corner. I delete so much, it can't be right. Yeah. I think this is correct. I want to get rid of the modulo 3 there, actually. Maybe I should wait with that. I'll do two things at the same time. Did we get here? Okay, that one now sucks because I'm passing a color. Some random Christmas music. Yeah. Orientation is no longer a color. This one doesn't simplify. Now we have to. Oh, I changed the set. No, it's probably not too smart. I think I'm going to let's do this later. And then, are you done with the orientation? No, yes. Where is it? This is at 80%. Now I jump to 76%. Is that the top? Oh. So that was the last one. At least this one gets simple now, because now we have index 0, 1 or 2, and I have to rotate it, which means that I'll have to rotate this one, yeah. Add or subtract CR. Let's say it is 0, 1, 2. We have to rotate it. Let's say 1. Just the other way around, man. Subtract it. Good, and this is the last one. I think I just have to look for the index in sides that equals C1. So you have to loop over all sides. Until we find it, and finding something with C1 and if we found it, then assign S, and then we are done, because we found it. So yeah, something must be equal to S1. That is then of course the pieces corner, something like that. Yeah, this is the index into pieces. Pieces index of the piece. Therefore, if we use that index as index into pieces, we get the piece. And then on piece, we can use the square bracket operator to access the side, the color of the side. So if that then is equal, then we found the index. And then it feels like I have to add an assert though. No, because this would already have asserted. If this returns anything, then C2 is going to be, or C1 is going to be an existing color. That looks really weird though, because... No, it doesn't look weird. I think it's correct. Something was not correct, because it doesn't even compile. Oh, I added an extra parameter. Yeah, okay, never mind. Do pieces. Okay, that should be the state of my current block cube. Let's see. Blue, white, orange, blue, orange, yellow, blue, yellow, red, blue, red, white. This is white. White, red, green, yeah. This is orange, white, green. Yep. Green, red, yellow, and it must be yellow, orange, green. Yellow, orange, green, yep. That is indeed correct, but we didn't use my function yet. So let's rotate bottom and then see if it looks still a lot like what it was, but then rotate it. How do I rotate something? Rotate. Rotate clockwise the bottom. Well, the top stayed the same, that's good. If we rotate the bottom clockwise, well, clockwise when looked at it from the bottom, that means that it's going this direction. No, it's not. What the hell? Yeah, it's going this direction, anti-clockwise, because now we look at from the inside basically. And that's what happened, I think. This one went there, and this one went there. Mostly. This is bullshit. Definitely didn't work. Okay, I understand what happened. Yeah. How can I be so stupid? this thing copies from pieces while writing to it, and we do it more or less in a random order. Stupido. I think I just I'll probably save is to make a whole copy of this thing and then do it. Same thing here actually. Either that or restore one of them and then do it in an order such that that wouldn't make things easy at all. So I'm not interested in making this beautiful or quick or anything. I just want it to work quickly. So let's do this the stupid way. Let's call it current pieces. These pieces. Current orientation is orientation. Nothing you needed here. Let's make these things const to be a little bit clear about their input and not being used as output or anything. But this is still the same, right? The top didn't change and also not compared to that. And this is GYO, I don't know. No, I have to look at this one. WRGOW, yeah, that's the same. And here we had 3 times the same piece, but no longer, yay. This should rotate anti-clockwise. That one went there, yep. That one went there, that one went there, and that one went there. And the orientation is the same, because I mean, there is no horizontal rotation, right? Because it's the bottom. All the colors that are at the bottom are the first colors, and they are still at the bottom because we just rotated the bottom. The same thing will happen if you rotate the top. That should just rotate the top, and the orientations should stay the same. Clockwise, so the BRW I mean, went here. That one goes there. That one goes there, which is here. And this one goes there. Yay! And this stays the same. Totally working. Then one step up is rotating, let's say, the front. Well, so now this one should stay, this one should stay, this one should stay, and this one should stay, and that worked. This one should go there to edit, and this one goes down, that one goes there, and this one goes up. So apart from the orientation, it rotated it correctly. And then the orientation, yeah, well, I better use my cube, I think. A real life cube that I have here. So if I rotate the front like that, then we end up with orange, green, yellow, white, blue, red, yellow, red, blue, and yellow, green, red. Yep, that's correct. Let's do the back. Back. Okay, I'm just doing it like this here. I mean, in real life here. The back is rotated, and I'm seeing yellow, blue, orange. Yep. White, green, orange. Also correct. This is white, orange, blue. And this is green, white, red. Yep. And the rest stayed the same, so that's still, yeah. White, yellow, orange, green, and green, red, yellow. Yep. Well, left. Okay, this should be red, green, white. And it is. That should be orange, blue, white. This one should be red, white, blue. And this one should be green, yellow, orange. And the rest is the same, right? Yep, good. Well, last one. That one should be red, blue, yellow. And now we have here orange, yellow, blue. Orange, yellow, blue. Green, orange, white. And red, yellow, green. Yep. Okay, rotations is coded in. Now to think of how to solve the thing. I think we can make a list of the simplest rotations. Just, you know, you can rotate left or right. Clockwise or anti-clockwise, I mean. You'll count those the same. So the primitive rotations, as it were. So we make a new class. Primitives, Primitive is an are all rotations that are well, the simplest. But I also need to store a rotation, or actually, how to store a rotation? It would be nice to be able to apply a rotation to a cube. But even if it is a complex, so yeah. It is kind of the same as this, except then for all 8 pieces, instead of just the 4 that are part of that side. So how do the pieces doing it is I think we need a loop 8 and then assign a permutation of the pieces, and the orientation does the same thing but applies yet another thing on top of that. Can we combine those? The permutations obviously, the orientation also, but I'm not so sure now. Yeah, probably. So you need something that can store an arbitrary manipulation, and you need to be able to apply it. Let's call those things operation. That then exists of these arrays, but with a size of 8. And I guess you only need a constructor for the identity. Well, this one doesn't matter because, well, I don't even have to store it. Here we have to store it because we only had 4. But then I put them in the increasing or ascending order. And if you have 8, that's always going to be 0 through 7. So yeah, don't need that. And then the from means that the identity means that the from is equal to the 2 and the 2 is equal to the p. So we just set this to p. And of course the corner rotations are just 0. No change because, well, they were not even the corners didn't even change place. Orientation doesn't change. Next, we want to be able to apply this to a cube. Let's allow an I want to return a new cube instead of manipulating a cube, because you have to make a copy anyway, like here. Let's allow a multiplication from the left with a cube. Which doesn't change the operation. No, does this make any sense? You fill pieces 2 with The pieces add form. I mean, what else could it be, right? It has to be right. Yeah, I'm not sure it will compile though, because now I'm calling square operator on cube. Not sure if that exists already. It doesn't. Okay, I did that because I wanted to access the pieces. But that returns an int. So we have an operator int. I don't know why I call it p actually. It's int p. Okay. This int p is an index into pieces. And then const return pieces p. But I'm also trying to assign to it, so yeah, really, who cares? I would never do this normally, but now I can write directly into the array because it returns a reference, which is not super object oriented anymore. Actually, I'm only reading from it at the moment. Yeah, this would work if it works, so do it like that then. Okay, whatever. Or we have to make operation a friend. Maybe that's less dirty. Less dirty. Okay, make it a friend. So the thing I did up there in let's not do this. To make a friend class operation. Probably better to for declare before we do that. Okay. What else? Operation. Assign the piece. And then we have to do that one as well. The result dot orientation to is, and then something like this, where current orientation is totally not working. So that would be in orientation. I'm just guessing, you know, like It wouldn't compile without an underscore, so probably need an underscore. Okay, I'm exaggerating. Yeah, I had the feeling it was nonsense, and it is. I think I have to do hello, the only ASDK. Are you sure you are the only one? That makes more sense. Oh, you're the same person. Oh, okay. No, I'm just kidding. I have no recollection of having seen you before. I need an accessor for the orientation at that index. It's again wrong. This is wrong. No, it's okay. I need to add an orientation to member function to cube. An accessor, as it were. Int orientation int. See, it's just confusing to call this operator square brackets. Let's call this one piece then. Makes more sense. Control H. Yeah. Okay. A while ago is just, I mean, a year. That's like forever ago. Not a while ago. Yeah, check if it compiles. It will not compile. Uninitialized const member in const struct standard or int. Oh, how lame. Yeah, you can't do that. Why are they const anyway? Who put that there? Hello, Sam. What is DRY? No, I'm not using KDE. Well, I'm not using Plasma. I'm using KDE applications. Sam, what did you want to ask? Because you said that it's marvelous work, so now I'm feeling totally flattered and really want to help you by answering your question. I don't know what it is. Pretty old, yes, but how is that? I mean, it's pretty absurd, yeah. Are you a really old guy, or are you Scottish? Yeah, not or are you young or something? No, you're either an old guy, or if you're not an old guy, then you have to be Scottish, or something. Nee, ik ben niet Schots, ik ben hartstikke Nederlands. My grandparents were Dutch. My parents are Dutch. I am Dutch. En ik spreek ABN. I doubt my accent is Scottish. But what does that all have to do with being old? Because the way I write my code? No. Oh my god, he writes like that. He must be Scottish or old. Class primitive. You mean I should have done this, right? Well, I have a reason for doing that, not doing that. I just like to put my cursor on something and then jump to the other one and then still be in the same column, because now I can indent like this. Well, the whole code block. And if you put it like this, then the class is also shifted, so it's sometimes very annoying. Mostly not annoying. Yeah, thank you. You're like the first person to wish me a Merry Christmas. I'm very happy with it. Well, maybe not true, because other people probably, yeah, Boys Bonnie said it, for example. In real life, seriously, nobody. Today I went shopping in the supermarket. And then it's hard not to feel sad that, you know, normally they when you leave, they have they pay a girl to say have a nice day to everyone, and then occasionally check if you're not stealing anything in your bag. But the idea is nice, and then I just spent first Christmas day all alone. And I forgot to do any shopping. I didn't even have bread in my house during this first Christmas day. So now the shops were open till 6 p.m. today, and I was like, no, I'm going to buy all kinds of nice stuff, so I will, you know, be able to celebrate Christmas eating nice stuff all on my own again. So I went there. And I bought some nice stuff. And then she was chatting with another girl, a colleague there, and she didn't even see me. And I left I left the supermarket and thought, this is my life. I'm not even being wished Merry Christmas in the supermarket, but the girl who's paid for it to do that. Yeah. It's a funny thing that when Christmas comes, I'm like, well, I rather be alone, and then when it actually is Christmas, then you suddenly feel self-pity every time. It's stupid. Primitive. So the primitive wraps an private. Private. Actually, I think that I was wished. I mean, I see people sometimes. And now it's the holidays, so then we don't have chess club, I don't have the other stuff. And then they all go on a holiday or they go to a big feast with their family. So they don't come and they don't have time. And then the last day of the last week that the club is, they leave before the holidays and they wish you a Merry Christmas and a Happy New Year in advance. More or less automatic. So I don't know how well they mean it. If they really meant it, they would probably say, "Hey, Carla, what are you doing with Christmas? What are you all alone? Do you feel like coming to us, maybe?" But they don't. They just say, "Bye, have a nice Merry Christmas." So, but yeah, they said it. They said it. Private, damn it, I should code. So a primitive is also an operation. I don't know why I would wrap that in a clause actually. Although we have to create all the primitives. And then list them, probably. Yeah, might as well make an array of operations and call that array primitives. It's maybe more logical. So we have an array of operation. How many primitives do we have then? 12, okay. Primitives. This totally wrote, no, that doesn't compile. Actually, it does compile. Can't type. You know what? I'm gonna turn on the lights again. Why is it always dark here when I get out of bed? Er is een licht. Primitives. Can't print primitives, but you can print cubes that are rotated by one primitive. No, it's not very clear either. Might as well try to print the operation. I don't know what it is. I'm starting to have problems with typing. Which is weird. Print standards. Stream reference. Operator. As a comma operation cons reference operation. Return is call on op print on OS. And this is printing it, as in opening brace and a closing brace. Roll 8 pieces, I guess. Yeah, or I can just put a comma at the end, because I want to continue with the CR anyway. Shall we combine that in here? Combine it. Rotate. Let's go all fancy. New code. Rotate here. It's going nowhere. Might as well close it. Search for. Really, no privacy here. What was I going to search for? Well, UTF-8 rotate. No, that, but then the other way around. Clockwise open circle arrow. In streams, nothing. In streams, no. I'm just coding. Well, I mean, it was kind of interesting that when I started, YouTube algorithm did behave like a pit bull. Like, oh my god, Carlo is streaming, let's invite the whole world. And everyone was literally spammed. Whether or not you liked C++, YouTube was spamming everyone. And they kept streaming in. At some point I had 200 viewers. Just simply because people were like, why the fuck am I told to watch this? What is it? I think the algorithm was like, well, it's a live thing and people are streaming in, so it must be important. So I will invite more people. And before you knew it, I had several thousand subscribers as well. So I don't know, maybe they accidentally clicked on subscribe. Yeah, that was, well, it was kind of interesting in the beginning. But I just kept doing what I do, which is extremely boring, and then it went down to 100 viewers, 50 viewers, 20 viewers, 10 viewers, 5 viewers, and now I'm at an average of 2 viewers maybe, if I'm lucky. I just never look at it. Yeah, I studied physics at the university. Class operation. Now I forgot why I was grabbing for this class. Because I wasn't. I was here, based in the rotation. Gaussian services. No. Well, maybe, but it doesn't ring a bell the way you say it. What is this? CR. I just want to print everything. Oh, that would be the identity then. 0 goes to 0, and then we rotate it not. And the same for the others, for all other things. Electrostatics. I know what static electricity is. I have to fill the primitives. What did I study? I just called physics. And then I started a PhD related to superconductivity, you know, in yttrium barium coperoxide. What is that called in English? High temperature superconductivity. I don't have good memories from that time. I never worked as a physicist either. I use Android. Is there a way around initializing an operation from a cube? So I have a cube and then I say what is the operation that is needed to go from the solved cube to this cube as a single operation, I mean. I think we'll just have to make it happen, because it's the only way, the only thing I currently have here. What is called the e-axis? E-axis. This makes sense, doesn't it? You run over 12 possible primitives that we have, which means one of 6 axes, and then twice that, because we want to rotate either 1 time or 3 times clockwise. So first 1 time and then again 3 times. Create a solved cube and rotate that axis that many times. And now we have a cube. And then we say, find me the operation that brings a solved cube to this cube, which is that thing doing. And then we saw that as a primitive, because 3 times clockwise means 1 time anti-clockwise, which is a primitive. Still have to write this one though, from cube. And it has to return a primitive. Well, primitives is actually an operation. Oh. Operation must return Might as well make it a constructor. Oh, what the fuck? Construct the whole thing. Or assign. Form a cube. Why would I construct it and then assign it? Hello hearts. Yeah, Graham, thank you. Goodbye, Johnny ASDK. I'll just be here coding. Primitives. Assign a cube to an operation. That's where I am. Operation. Multiply with the cube, and now we're going to do assign from a cube. Does that return something? Guess assignment has to return that. It's probably just a few lines of code, but oh my god. How? Seriously. I bet a loop is involved though, because we have an array, size 8. And then in its simplest form, we would just be able to, you know, sign it. Wouldn't that be nice? What does the form even mean? So we're passing the result, and original is the salt cube. That means that whatever operation comes out of this, if applied to the identity of the salt cube, should give us the result cube here. So if we pass the identity, which is this one, to this function, then the operation should be such that the result is that result. Which means, if I just copy this line for an arbitrary 2, so in here is the identity. That's what we said. If I call piece on the identity, that returns an integer equal to p. So piece returns its own argument. The orientation returns 0 for the identity. Now, turn that around. I don't know, it doesn't make sense, but it should work. Trying to understand it in another way. From 2 is result P is 2. Why would that make sense? Because from was the piece at index P becomes the piece that currently is at from P. So the piece at 2 will becomes the piece that is currently at result pieces 2. Yeah, it's incredibly trivial and clear. It's exactly what it is. My God, really. Okay, so, well, that would be the from one then, and the CR. Probably as easy. Try to do that the same way. So we have this. And I'm gonna fill in in is the identity. This in is the identity, and then afterwards this result should be that result, which means that yeah, and the orientation of any identity is 0, so we can replace this with 0. And then I have to solve that for CR2. So we can do the whole calculation modulo 3. And then begin with ignoring that. And then we just have that CR2 equals, well, the negative of that thing, which is we do exactly the same way again. Add 3. Yeah, I guess. Okay, so this would be the rotating the other way, then, well, applying 3 times this one. Can I understand that? So 1 goes to 3, do that again, then 3 goes to 2, and do that again, then 2 goes to 0. Which means that after doing it 3 times, 1 goes to 0. That looked good. And 3 goes to 1. Comes from 3 goes to 2, 2 goes to 0, 0 goes to 1. Yeah. 0 goes to 1, 1 to 3, and 3 to 2. Therefore 0, 2. And 2 goes to 0, 0 to 1, and 1 to 3. 4 stays on 4, 5 stays on 5, 6 stays on 6, and 7 stays on 7. Yeah. There is no orientation change because this is the top. This is the bottom, so also no orientation change. And now these stay the same and these change. Much in the same way, I guess. Yeah, it just works. How could it not work, right? Let's see, 5 goes to 4, 4 goes to 6, 6 goes to 7, 7 goes to 5. Yeah. And this must be the reverse of that. 6 goes to 4, 4 to 5, 7 to 6, and 5 to 7. Yeah. What about this one? This is 0 goes to 0. 3 goes to 1. This is the front, is it? I forgot how the cube looks like. Shit. Too many. Which one was I doing? This one. That is 0 goes to 0. 1 goes to 1, 2 goes to 2, 3 goes... That's totally not the one that I wanted. This one then. 2 goes to 0. And 1 goes to 1. 6 goes to 2. Okay, so this is the left side rotated anti-clockwise, which is correct. What about this rotation then? Two goes to 0 and then a 2. Yeah, it's correct. 6 goes to 2. And then a 1, I guess, yeah. Yeah, that must be okay then. Next, I guess I have to brute force this, right? I was going to brute force it. So I'm just going to make a set of operations from the simplest operations to more and more difficult operations. And then hopefully within the time allotted to us in this universe, we'll find my current cube and then apply those rotations backwards. And then I have solved this. Therefore, this means that we want to have a loop. Let's say a number of rotations, a number of primitives. So at index 0, which is the first one, we want to have the solved cube, because that would be zero primitive operations. And that is a default constructed operation. And then you have to add all the primitives themselves. But that won't work what I do here. I want to push back a vector as a single thing in it. Do not do emplace back. Emplace back and then pass arguments for the inner vector, which is just 1 then. Size, so that would be the size, and the the size is then constructing a default constructed operation, which is the identity. Okay, let's place back a vector that is empty. And then I can use ops back to get that vector. So that would be the inner vector now. And then we want to add all the primitives, which are literally stored here. And then we're going to do the 2. So again, make an empty vector. And then that one must be filled with applying operations on each of these, but not those that end up that are already stored in a previous one. So I have to run over all elements of the previous vector. Run over all operations in the previous array, or vector, and then apply to each of them all primitives. I don't think I have that yet. Applying an operation to another operation. So this is left to right, so first apply op and then apply PR. So you second. And that would give us then the new operation existing of whatever previous was plus the new primitive. Let's do that only 5 times or something like that. It's already a bit much. 5. Doable maybe. Oh, we started to. Should be doable. What a horrible music. Yep. So I have to write the multiplication operator for two operations. Boy, how do we do that? Yep, 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 yep. This way or the other way around? Let's say the right hand side moves, I don't know, 3 to 5. And the current one, which is the left hand side, moves moves 2 to 3. And moves 5 to 1. And number 3 moves to 1. This it's the other way around. Yep. Okay. And this one. Result. Clockwise rotation. The orientation to is what? just add them. Orientation, no, correction, rotation. After doing the right hand side first. Pretty sure it's a summation, so let's say CR something plus right hand side CR something. I think that this must be 2. Yeah, seems logical that this then has to be from 2. Yeah, I mean, really. It's that just basically has to be like that. I'm not 100% sure, but what else can it be? It's also, you know, it looks like the same thing here, just from to, and then CR also from to. That was insanely fast, so I doubt it worked. Maybe it did work though. Uh-huh. Well, now we're just blindly applying all 12 primitives. So yeah, this should be powers of 12. 12 to the power 2, 3, 4, 5, 6, 7, of course. Is yeah, that's correct. Yeah, we wrote a program that can calculate the power of 12. So it isn't that simple, of course, because every time we find a new operation, we have to store it. Store it in a map, I guess. At this point, it would be very, very nice to have a hash. Maybe even a perfect hash. 64 bits. Let's make these things a bit smaller. It was considerably faster. Yeah, 8 bytes would be 64 bits, but then now we have 128 bits per operation. Surely we can compress this even further, because this is just 2 bits each, so that's in total of 16 bits. And from is 0 to 7, 3 bits. So there's 3 bits and there's 2 bits. I think I should combine them into one array. To see if this compiles. So I think that we can access now FC form instead of form. That should work, and the other one as well. Yeah, there's no reason to test that, it's just working. Oh no, what? Oops. Yeah. No, just that didn't work. Let's see. What did it do here then? I think that one worked. Oh no. Can't even remember what this was. Yeah, if it works, nobody knows, but I think so. So now we have something, well, 5 bits, 40 bits in total, but we can fit that into 64 by just using a union on the array, I guess. Let's call that a hash. That's not a hash, it's a perfect hash. Let's call it ID. It's too full. Not 100% sure though. Standard mem copy docs destination source. It's an array, of course. Yeah, never mind that. Data. Yep. ID. We have an ID now for the operation. So now we can make standard set or something. Would be the fastest way to do this. Fastest way would be to use a huge array. Hell, to use a bit set. No, not really. A bit set of 2 to the power 64 bits. I probably should not use a vector of vectors. You can do this in one vector. The only problem is that I'm actually reading from it as well. Can't insert into the vector while reading from it. Oh, yeah. Guys, look, let's do it like this. Okay. Okay, now to skip the ones that already exist. I'd like to have a try. There's only a try in place. Mm-hmm. In IBP, iterator Boolean pair. MIP try in place. ID, comma. Yeah, new, whatever. Use copy constructor. And then IBP iterator Boolean pair. So that, oh no, iterator is first. Second equals. I return type. A pair consisting of an iterator to the inserted element or to the element that prevented insertion, and a bool value is set to true if and only if the insertion took place. So if it took place, then it was a new one, and if it is a new one, then we want to insert it. No, then it was already inserted. What? Mm-hmm. Yeah. So we have an identity, and all my primitives, all 12, are changing the identity. And then if you apply that again, these primitives, and I guess every primitive is again changing the cube, except the inverse of it. So this should be, I think it's a bit small actually. Or is it 11 times 12 or something? Or what is it? What should it be? I think it should be... Oh yes, indeed, there's more that drops out. If you rotate to opposite layers, then of course it doesn't matter which one you do first. 114 might be just right. Now we can do more, I suppose. It doesn't grow that fast anymore, or it's also slower. Yeah, I'm not gonna wait for that yet. Too slow. Just one more. Ooh, that's already slow. It's still growing. Yeah, hopefully we can do this brute force to begin with. So it's a small cube, only 3 pieces are wrong. So let's see if it's already found to the resulting cube. I can convert the cube maybe to an operation. Oh, I totally can. Not sure if that is the correct operation though. It's the operation that brings the identity to that cube. I think I need the inverse of that. Yeah, it would be nice to have an inverse, an operation inverse. I'm gonna ask an AI because I'm getting a bit tired of this. Oh, must be in projects to run to use that. That's only because the environment, blah. Yeah, I don't have anything set up. If I run Codex on this, then it's gonna say I'm going to tell Codex that it can use certain environment variables, which it cannot. But I can still copy it and do it in the web, I suppose. Got X clip. Which AI shall we ask? Ask Claude. Free plan. Hopefully it will work. Upgrade. You must be pro to use Opus, unfortunately. Yeah, okay, I'll just ask, I'll ask TTP then. Oh, this thing is already working. Codex is working in some repository, so it's totally not useful here. Not usable. Just to paste it here. I have root following program. That should, well, that is meant to solve a 2x2x2 Rubiks Cube. Can you please write the function? No, should it do? Operator invert. That should invert the current operation, so that applying it before or after itself results in, well, the identity. Well, it ain't stupid. Definitely not. I mean, you just dump this code on it and it just figures it out. Pretty impressive. What happened? Oh, 446 fuel lines. A bit much. Copy code. I don't know where it copied it to, but stripe paste. Yeah, much better. Bleep bleep. Yeah. Or not, you know, like it does something and then you are impressed, but only if it is correct. This is not correct. Oh, actually it is. Sorry. I completely missed that. I was looking for a word that is actually the CR here. I just didn't see it. Well, in that case, it might be correct. No. Well, I'm just going to assume that it is correct. So now we can construct a cubic from, or an operation from my cube here. So I do operation. Scramble. Construct from cube. And then we can do operation solution is scramble invert. Looking for solution. Solution. No matching function for call to operation cube. What? I thought I could create an operation from a cube. I had added that. Pretty sure I added that. Oh, now we can only assign to it. No. Yeah, well, whatever. Okay. You think we can do copy assignment? I think that should work. You cannot do that. How stupid. So we are looking for a solution that is not printing anything whatsoever. In fact, this is also no longer printing anything. What the hell happened? Probably already broken for a long time now. Yeah, just never noticed it before. Here we still have something. Still. Yours is broken. I think it is just a problem with printing. It is just a problem with printing. Print. It's just a problem with being an unsigned char. It usually doesn't work if you print. Instead of cast int or unsigned int maybe. Int is good enough. Same thing here, of course. Yay, the parameters are back. Okay, looking for a solution. Well, I'm still looking for it. And it is 0 goes to 0. Can I get my thing back? 15 minus 3 is 12. Oh, that was a time a while ago, apparently. 15 minus... So I think also 11 actually. Well, I'm gonna try 12. Yeah, could have been 11. 0 stays at 0. Yes, that is correct because it is already at the correct thing. And same thing for the whole top layer actually. So 1 also doesn't change. 1 stays at 1, 2 stays at 2, 3 stays at 3. Now we get something interesting. 5 has to go to 4. Is that correct? 5 has to go to 4 because... Yeah, correct. And then it must rotate... That should not rotate. Oh, it says it must rotate. Why? Oh, yeah, green comes here. Yeah, correct. It must rotate 1. And then this one is 6 goes to 5. Where is 6? There. That must go diagonally to that side. Yeah, that is correct. And then it must also rotate 1. Yeah, also correct. And this is 4 go to 6. 4 must go to 6. That is a red, white. Yep, that is correct. And white stays here, so also 1. Oh, completely correct. That is the solution that we are looking for. Guess the inverse worked. Then, my friends, if we get here, if a new op hash, or just calculated the hash, you know, did I not? The ID here. You should have well calculated. It's not doing much. It's probably a no op even. Okay, let's be nice. Bring this back. Get the ID of the new operator. And then if the ID equals to the ID of the solution, we are done. Well, I mean, I'm an idiot, Const. And also exaggerated. How far the const goes to the right. Print it, damn it! No, that's not printed. Yeah. How long is this going to take? That is, of course, the question. I don't want to run it a billion times. So maybe I should, if we find it, immediately print the solution. At the very least, I think I can just, no. We need all the primitives. So I'm afraid I have to store the primitives as well. Collect all the primitives. It's not that easy. Yeah, you kind of have to store a pointer to the, at the very least, the previous operation, from which then the PR, the primitive, can be deduced if necessary. And the operation itself, that would be op. This op. That's kind of also a standard pair then for the indexes. Except that I know what n is. N is n minus 1. Just storing the index of op would be enough. Okay, so I'm going to do int j is 0. I'm just going to run over it. Run over the indexes. J is 0, j is less than. No, okay, maybe not. Yeah, or semicolons. That's what you get when you put something on one line that should not have been on one line. Hmm? So the last primitive was PR. Going to print PR. And then I want to go back to the previous PR. How do we do that? Oh. Well, I just rotated it, just did 2 rotations, so they should totally have found it. Why is it not finding it? Nope, that's not what. That isn't it. Rotate. I think I can do with one less. Okay. I rotate the front first, which is number, well, the second last one. It should be J5 then, right? Oh, we have a lot more. Left and right, yeah. So go do it clockwise. Yeah, do it clockwise. But it should be J5. This should be the cube with the front turned. Doesn't look like it. Yellow, blue, orange. Yellow what? Yellow, blue, orange? Doesn't even exist. Yeah, what? Oh, it does exist. And again, I confuse white and yellow. Yellow, blue, orange. Yeah, that would be the back face being turned, not the front. That is if that one here becomes white, orange, blue, yeah. And this one, look at that, these must be still the same. Blue, red, white, blue, yellow, red, green, red, yellow, and green, white, red. So JS5 is that's because it's 4, isn't it? Yeah, it is 4. This is the second last one. So this one has the front rotated. Again, blue, white, orange, blue, orange, yellow, blue, red, white, but it is now different. That went there, so it must be white, blue, red. And this must be okay, this was green, white, red. Green, white at the top, so it's white, red, green. Yeah. Yeah, this is the one that's J4 is the front rotated. Yeah. But. Well, yeah, we're going forward, so that's correct. That's correct. This runs over the primitives again, and I want to find the one that does left. So we do front, back, left. No, we do top, bottom, left. Well, anyway, it's the number 2, so 0, 1, 2. So the third time we print this. That's a 1, 2, 3, which is meant I has value 45. That should print the current cube. I wouldn't know why not. Anyway, so the second one is left rotation. Should be the left rotation. The left rotation means that 4 is going to 0. Yup. 1 doesn't change. 2 doesn't change. 2 goes to 6, I see. What the hell? The 0 goes to 2. Okay. 2 goes to 6. Okay. 6 goes to 4. Yeah. Never mind that. So 3 stays at the same place. Now what? This is 3. This is 1. Yeah, that looks like a left rotation. I agree. The cube is now, and yeah, that doesn't in no way look at like that thing. Why? Why is it not the same? Oh, wait a minute, sorry. This one, of course. The current cube. Thank God it is the current cube. Yep. So this cube is equal to the current cube, which means that we have found the solution. But apparently not. It's not detecting it. So here, new op calculates PR times op, where no, it's the same bloody idea. Oh, and now it prints found solution. What? It didn't do that last time. I think I caught it, you know, I caught it on a... Oh, wait a minute, yeah, no, now you add that debug output, I see that I should have found a solution. What ridiculousness is this? Really? Pretty sure the only thing I added was this. And at the top, print. It just print 2 prints and suddenly it finds the solution. Can someone please explain? How am I supposed to debug this? Pretty sure that this was the difference. This and the line here. See? I removed 2 prints and now there's no solution. Why? What is going on here? Blackout. Shit. What is the name? Oh, this is scary. I'm so getting Alzheimer. No way they cannot remember that command. It's just doesn't pop up. Anyone knows what is the memory mangling thing? It simulates the program and finds memory errors. I don't know. Man, ridiculous. Valgrant, yeah. Fuck, man. Why? Undefined memory. Okay. Well, why is there undefined memory? Hopefully there's still undefined memory if I compile with, well, it should be, of course, just G. Yep, way more information. Conditional jump or move depends on uninitialized values. 3 map main. Call from line 464. And then again at 498. Maybe it's the ID itself. ID is undefined. Oh, okay. No errors. And it found the solution. Oh, we found it. Okay. The original cube was that. It's not the same thing, man. Why? To be the same as this. Guess the I equals 45 is wrong. What to do? Yeah, that's not the same as that one. That is not the right rotation. It is I is 44. Oh boy. Then we do I is 44. But yeah, it already works, right? I just want to check if it... I don't know why I want to check it. It's just found a solution. Okay, so 4 goes to 0, which is correct. 1 stays in place. 0 goes to 2. 3 stays in place. 6 goes to 4. 5 stays in place. 2 goes to 6. 7 stays in place. Yep. That is the left rotation. So now we do a front rotation and a left rotation, and then we found it, and now I want to print the solution correctly. And what it prints is the last one. It should print the last one. It's totally not doing that, is it? What is this? 3 goes to 2. That's a front rotation. Counterclockwise. 7 goes to 3. Yeah. What? 0 goes to 4? No. Hello, John is. I think I'm almost there. Started early today, as in, well, not in the evening, but in the afternoon already. Because I want to finish this today. And I think I'm basically, well, there. Except for a few lines of code that are still wrong, apparently. Among which printing the solution. It is not printing the solution. Okay, let's just go back at the code. We found the solution, and I call print solution. That now worked. Now n here is equal to the number of primitives that have to be applied, and then I is the index into the just added thing to get a new ops. I mean, like I is set to the size of cur, and then we increment cur with 1. So now the last index is equal to the previous size, and that contains a new op. So cur index I is the last operation. That is the new op. And it is not, it is the total operation. Aha, okay, that makes sense. Yeah, okay. So we print the total operation instead of the applied primitive. Yeah, but it's okay, I guess. You just have to figure out how to get a primitive back. Suppose you can multiply this with the inverse of op from this side, and then that cancels out, and then you get the primitive. So if I have this and I have op, then I can print primitive. This is the total permutation. So that should again be equal to this one. No. What is this equal to, man? Oh, that is the solution that we're looking for. Yeah. Mm. Yeah, what is that? I think I need to look in the map. Add probably an ID and then get J, I suppose, because I didn't use that yet. Very intelligent programming here. Where ID is then ID is the ID of this operator. I don't have identity yet. Need to write identity on operator. On operation, I mean. Ticklish. Cannot even use this constructor, it is plain inside here. just because I'm defining this inside the class. Oh, okay, I'll put it outside the class. But it is... Oh, actually, I can't not do that. Well, I can't do that. I'm just doing really bad, horrible things here all the time. Oh. Doesn't make any sense, if you ask me. Okay, screw this. No cons expressions then. Passing const map discards qualifier. Oh yeah. Stupid map. Okay, do add or something. I have to use find. This is so ridiculous. Oh, it's a pair. It's not a pair. Because no, it's an iterator. Right. But yeah, instead of printing the total scramble, I want to print a solution. So this is the current state, and this is the state that we want to go to next. Then, so I want to print the operation that sits between these two, and then the operation that sits between these two. Because well, this is the unscrambled state. How to do that? that's not how it works. You have, there is a PR such that PR times next is lost. I want to find that PR and then print the inverse of it. I need the inverse of next. Invert. That doesn't feel 100% right, but it probably is. Looks right suddenly. Yeah, that is right. But does it compile? That is the big question. Also that it just compiles. Where's my deck version? Or do I not need that? Maybe I don't need it. Don't need it. Picks up tags anyway. Okay, so now I have PR. I would think that I just have to what to do next? Yeah, let's begin with just printing it, I suppose. So after having reached this scramble, we apply that operation and then we get this scramble. Is that correct? Well, 3 is still where it was, and we apply, 3 goes to 2. So now we have the scramble, 3 is, well, went to 2. That looks correct. What about the rest? 2 is still at 2, and we send it to 6. Therefore, oh. Oh, 2 is, sorry, it's 0 here. It's not 2 is 2. Yeah, 6 went to 2, and then we do 2 goes to 6. Which means that 6 stays at 6. I'll just start here. 2 goes to 0, 0 goes to 0, therefore 2 goes to 0, 1 goes to 1, 1 goes to 1, therefore 1 goes to 1, 6 goes to 2, 2 goes to 0, therefore 6 goes to 2, 2 goes to 6, therefore 6 goes to 6, 3 goes to 3 to 3, 3 to 2, therefore 3 to 2, 0 to 4, 4 to 4, 0 to 4, 5 to 5, 5 to 5, 5 to 5, 4 to 6, 6 to 7, 4 to 7, 7 to 7, 7 to 3, 7 to 3. Totally looks like this is now the one that is applied after that. So to go backwards, yeah, it is need inverse now of this, assuming that this is indeed a primitive. Let's just get the inverse first. And then let's get the ID. And then let's look up that ID, as in, let's just first print actually PR inverse. Yeah, and then in order to find back the actual primitive, let's just call another function to do that. I'm just going to use the ID, I think. Nah. Okay, I'll print the ID and primitives. No, yeah, well, yeah, no. I need a mapping. I might as well look it up. Add in another global because while I'm at it, in 64 type. Primitive to, let's say, standard pair of an axis and a direction, left or right. Primitive map. Once that is filled, you can just do yeah, I have to still fill that bloody map. This map. So the run over all the IDs, sorry, all the primitives. Which gives me this, which is an operation, isn't it? That is an operation. So primitive ID can be calculated here. Div ID standard make pair, and then again an axis, an axis and an clockwise boolean, which you can copy from here. That would be the axis, and this is then a boolean clockwise, where clockwise means true and false. In other words, y is less than 6. No, can't print something. What can we not print? Oh, we can't print void. That's not how we should do it. No. Yeah, okay. Never mind. I'm guilty. I admit it. I'll just call that then. How much I'll add a new line to it. Print primitive up here. Yeah, we'll go them. Why not? Session bit is unequal prim map end, so it's not primitive. Jesus, DB starts throwing the colors. What? No. Debug table. No symbol table, I mean. Oh, it's a bloody bug. It comes with a red UTF blah blah, and then it says reading symbols. How about doing that the other way around then? I probably executed something from .gdb in init or something. Yeah. Okay, so it just printed this thing, and apparently that's not a primitive. PRINF, that would be this one. 0 stays at 0, 1 stays at 1, 6 goes to 2. Two goes to 3, 4 stays, 5 stays, 7 goes to 6, and 3 goes to 7. Now, do I really have to check that also from my head? Let's see, 6 goes to 2. Where is 6? 6 is there, I think. 6 is there, and this is a front rotation quarter. So that should end up at the top, but it ends up there, which needs 2 rotations. Yep. Let's see, 0, 1, 2 goes to 3, so that should be, but it end up there, so 1 rotation. 7 goes to 6, 7, 7, 7, 7 is for 7, 7 is there. 7 rotates like that, goes to 6, yep. So that should be at the bottom, but it ends up there, so 1, that is correct. And this is also correct, because we already had 2 1s and 1 2. I'm not going to do that one. Am I not? I might as well do it. That goes there, that one should go there, but it ends up like that, so we need... wait a minute. 2, yeah, okay. No. Yeah, 2. Now, this looks totally like a front rotation of a quarter. And if that is a solution, I don't want to say, but it definitely is a primitive. So why was that not found? Let's print all the primitives that we add and all the IDs of all the primitives. Where did I do that again? Oh, here. Standard cout adding primitive. Just call this, even though it prints a new line. Well, this is only printed once. Adding primitive top clockwise. Oh, this is a no new line after the with ID. Let's add it. It's unreadable. Yeah, 6 times clockwise, 6 times anti-clockwise. Top, bottom, left, right, front, nothing. Top, bottom, left, right, front, nothing. Well, apart from the nothing. Hello, Ed. Yeah, maybe back is not being printed. Why? Because it's completely missing. That's why. Front back. Yeah, okay, these IDs are like very small, not nothing like what what we are looking for. So I would say this is probably correct. And then these IDs are just nonsense. So why? Why are these nonsense? What is missing then in my operations there? Suspicious. Weird. Why? So we're adding primitives IDs here. This prim ID is wrong. Why? Well, because the type is wrong. Int 64 type. And now it probably does work. Wrong type. Got cut off. Found solution. Takes 2 primitive 90-degree rotations. Front clockwise, left clockwise. Now the only problem I have with this is that I had expected them to be in the other order. Or is this a forward solution? So I have to read it backwards. And then invert it again? No. What? Why? It just prints out how it was created apparently. So I make this, for example, right. Rotate it 3 times right, then it should print, you know, anti-clockwise right. At the end. No, right anti-clockwise. So this is not how to solve it. This is how to create it. But okay, then we can do the opposite. I would rather get a solution though. So I have to print this in reverse, and then I don't need the inverse. PR was already the correct thing, apparently. Gonna add one. Rotate top. Oh, the top twice. Nah, maybe it becomes too much. Nah, I don't know. Maybe. Definitely going to need to increase this here though. Otherwise we'll never find it. And then do not invert it. Oh, I'm looking at what? somewhere that it is missing, I think. So I must print the inverse. Okay. To rotate it the other way. But how does it end? I really don't get this. I don't get it. Let's do more optimization. Solve. It starts now with front. Well, yeah, that is how we make it. But now I printed the opposite thing. So okay, yeah, no, yeah, well, it works, but you have to start here then. That is so weird. I have no idea how that works. How is that possible? This doesn't make any sense whatsoever. Scary. What? Eh? I mean, this is the most scrambled state. Yep, so that is the most scrambled state after we do the last turn. And then we reached that by doing a top rotation, not a front rotation. It's impossible, this. I have no idea how this got reversed. Impossible. Absolutely impossible. Unless it is reversed because of the stack. No, I'm printing it first and then I'm calling in the next print solution. Well, can reverse them like that, but makes no sense. It still makes no sense. I don't understand this. Okay, so now it says do that and then you solved it, right? And that seems correct, I would say, because that would be the opposite of this. So we did rotate the front clockwise and then the right side clockwise 3 times and then the top clockwise. Then to go back, rotate the top anti-clockwise, then rotate right once clockwise, and then rotate the front anti-clockwise. That is the solution. That is the solution. Yep. Oh, okay. I'm going to solve my cube now. We don't need this. Where is the thing that limits it? So let's remove this as well because we don't need that anymore. And this. And N is limited. Let's remove the whole bloody limit. Why did it print some stuff? J equals 4. Well, that probably I'm gonna stop it. I don't want it to print that. What was this? Let's print N, however. It's the number of moves that are needed. Or that it is working on, rather. Yeah, how many rotations are needed? Hopefully not 15, because that's gonna take days by the looks of it. It's quite slow, isn't it? $14. Wow, that's not 15. God's number. Oh yeah, that's of course, because if God would solve the Rubiks Cube, he would do it in the minimum number of moves. Yeah. Okay. Well, where is the 2x2 solution? Yeah. Well, why is it taking so long then? I'm confused. It says that... Yeah. Takes forever. I would think there are more solutions than a few million. Come on. Impossible. Found solution. Yay. Let's do this. Okay, here's my cube. And we have blue at the top, red at the front. And it says top clockwise. I hope this is going to work. Because left clockwise. Left, that says clockwise. That gets even more scrambled. Front, anti-clockwise. Okay. Top clockwise. Front, anti-clockwise. Left, anti-clockwise. Front, clockwise. anti-clockwise, back anti-clockwise, this way, right clockwise, that's right, clockwise, back anti-clockwise, back anti-clockwise, anti-clockwise, left anti-clockwise. Fuck me, it is solved. Oh yeah. Absolutely awesome. Well, I guess that concludes who wants to have the program